Hello and welcome to today's class. For today, we'll be trying to solve some past questions based on motion, right? So last class, we have discussed about motion in our last class, right? So I'll drop the link to our first class on motion in the description of this video. So watch that one first before you dive into this one, yeah? So for today, we'll be trying to solve various JAMB past questions and WAEC questions, right? Based on motion, right? Before that, let's try to recall what we said last class. In our last class, we discussed about 7 equations of motion. We said 4 are equation of uniformly accelerated motion. We said 3 are what? Equation of free fall. So I'm going to write them out here. So last class we discussed about the equation of motion. So equation of firmly accelerated motion. I gave you for this one, I gave you 4. I gave that v is equals to u plus at. The second one, you said v squared is equals to u squared plus 2as. And the third one, I gave you that x is equals to ut plus 1 over 2 at squared. The fourth one here was that x is equals to u plus v all over 2 into t, right? These are like the 4 equation I gave you under uniformly accelerated motion. For free fall, we said for free fall, it's still the same thing, but what changes there? Your a changes to g, your s changes to h. So for free fall, I'll have that this is 5. I'll have that v is equal to u plus gt plus or minus 6. I have that v squared is equals to u plus 2gh, right? Yeah, v squared, u squared plus 2gh plus or minus, please. Plus or minus. And my last one, which is s is equals to ut plus or minus 1 over 2 gt squared. So I have these 7 equations of motion. So your ability to answer any question on JAMB or WAEC is that, can you recall this formula? If you can recall them, then you are good to go. Let's start example 1. Right, example 1 says, if it takes an object 3 seconds to fall freely to the ground from a center height, perhaps from a certain height, what is the distance covered by the body? So I'm given that option A. Option A there, A is 45 meter. Option B there is 60 meter. Option C 90 meter, and option D 30 meter. So in this case here, I'm told that it takes, so that question there that I give you now is a question of free fall, because you can hear the word fall freely. So that's a question of what? On free fall. So I'm using this equation. That's the sense, that's the idea. So the question says, if it takes an object 30 seconds, so I'm given time. So time is what? 3 seconds perhaps. So solution, time is 3 seconds to fall freely under the to the ground from a certain height. What is the distance? I'm looking for s. Distance. We said distance here becomes what? Your h, because it's free fall, so it becomes h, because I'm hearing the word fall freely. So it's a problem on free fall. I'm saying for free fall, your s changes to what? H. Sorry, it becomes h. Sorry, h. Yes, h. Yes. All right. That's like h there, please. All right. Next task. Observe that from the question, these are all what I'm given, right? These 2 parameters. But still yet, I can still get out something from it. The question says, if it takes an object 3 seconds to fall freely to the ground from a certain height, the object was at a point. right? It means that at that point, its initial velocity was what? Zero. That is, u was zero. So u, initial velocity is equal to zero. That's u. Let's say u is equal to zero. That's like the idea, because the object is at it takes perhaps if it takes an object 3 seconds to fall freely, right, to the ground from a certain height. So it was in a position before it started falling. So whenever a body is at a initial position, its initial velocity is what? Zero. That is, u is zero. So from here now, I'm having time, I'm having u, and I'm looking for h. Under free fall, check your equation. Which one goes with this? For me to look for distance, h. Of course, I can use this man here because I'm looking for distance, which is h in this case. So I'm having u is given here, t is here. So I can use this equation, right? So gravity is just 10. I know that one already. So using this equation, recall that we said h is equal to what? Ut plus or minus. Now look up. I'm having plus or minus here. So which am I using? Am I using plus or minus? Observe from the question. They say that if it takes an object 3 seconds to fall freely to the ground, so it's falling to the ground. So it is a motion, is a downward motion. I would say for down motion, use positive sign. So it seems I'm using positive sign there. Plus, so I have 1/2 gt squared. So I'm looking for h. So h, it means that h is equal to, what's u? You said u is 0 multiplied by t. What's t? Is time. That's 2 plus, I have this one encased. I have 1/2 times gravity is 10 times time is what? 3 all squared. Alright. So at this point there, my height is equal to 0 plus 2 here 1. 2 here is what? 5. Right. So we're having what? I'll be having 1 times 5 is 5. Next up, times 3 squared is 9. If I multiply 5 times 9, my height there will be 0 plus 45. So add them together, I'll have 45. Height is what then? In meter. So this is my answer. Question answer A, 45 meter. That's my answer to that question. Let's take example 2 and understand the concept there. Example 2 says, a car travel at a uniform speed of 100 kilometer. So I'm giving speed there. That speed, all right, I'm giving speed there. All right, I'm giving speed, also known as velocity, right? Or perhaps you call it velocity. So as what? I'm giving speed as 100 kilometer per hour. So is a car travels at a uniform speed of 100 km per hour. It takes 15 seconds moving from point A to point B. So the time taken, that's T, here is V, right? So the time taken, is T, that's 15 seconds. All right. Moving from point A to point B along a route, right? So the distance between A and B is dash. So what's distance? So I'm looking for distance, right? That's d, right? So how do you look for distance here? So I'm having speed, time, and distance. What's the relationship between speed, time, and distance? We know that speed is equals to distance over time, right? Before that, let's observe something. My parameter here are not correct here, or perhaps they're correct, but the SI unit, I'm having kilometer per hour, right? And kilometer per hour, this is 15 seconds. So convert this hour to seconds. So it becomes, I don't need to convert my kilometer to meter. Just convert your hour. This is seconds. Convert this one to seconds, so it becomes 100 kilometer all over what there? 60 times 60. So I have 100 kilometer over 3600. Divide this, my speed there will be equal in value to, if I multiply, if I have 100 divided by 3600, I have 0.027 kilometer as my speed there. So it means that from here I've gotten per second now in this case. So I've converted, this is seconds. I'm good to go now. So we said relationship between speed, time, and distance is that speed, if you can recall, speed is equal to distance over time taken, right? So for me, I'm looking for distance. So take distance here. I'm having over 1 here. Distance times 1 is distance, is equal to multiply the two, that's speed times time. So we can say that distance is simply the product of speed and time, right? So it means that distance is equal to what speed? Speed is what? Is 0.27 multiplied by time. What's time? 15. So if I multiply this by 15, I'll have that distance is equal to 0.416 in what? In kilometer. I'm having kilometer here, so it's being in kilometer. So my option there is option A. All right, option A there. All right, let's take example 3 and solve together. Example 3 says a boy travels 8 kilometers to a point B and then 6 kilometers northwards, right, to another point C. Determine, or perhaps determine, the difference between the magnitude of the displacement of the body and distance by him. So it's quite simple there. My first task is to look for displacement. Next task, look for distance. Then subtract the two. That's all. First task there, I'm given, look up. Let me show you the diagrammatic expression for this question. So the question says a boy travels 8 kilometers to a point B. Let's say the boy travels solution. Sorry. So the boys travel, let's say it gives 8 kilometer. Let's say this point here travels 8 kilometer to point B, 8 kilometer to point B there. And then 6 kilometer northward. You know, you have north, west, east, south. North is facing what? Upward. So I'll have from this point, it now move upward like this to point C. All right, this is a point C here. Of how many kilometer there? Of 6 kilometer. So this is like a diagrammatic expression for this question here. So the question says, determine the difference between the magnitude of displacement and the distance by him. So I need to get what displacement first, and then get distance. The two values, subtract them, you are done. So but look up, the option here says A is equal to 2.0 kilometer. B says 4.0 kilometer. C says 10.0 kilometer, and D, I have 14.040 kilometer perhaps, right? So let's get the displacement first. So displacement is equal to, what's displacement? Displacement is the total distance covered by body or traveled by body in a specific direction. That's all. So it means that if I sum up these two distance, that's the displacement there. So I'll have that 8 kilometer plus what there? 6 kilometer, right? If I sum up 8 kilometer plus 6 kilometer, I'll have what there? 14 kilometer as my answer to the displacement. I've gotten displacement. Next task, let's get distance. Then you subtract them. We are done. So to get distance, what was distance? We said distance is the space between what the 2 points. Look up, I'm having this point here and this point here. So the space between the two of them here is the what? Distance. Let's call it x, right? From here now, I can infer the concept of what? Pythagoras theorem here. To get x now, apply the concept of what? Pythagoras theorem. So it means that x squared, or perhaps let's say for distance, For distance, I'll have what? X squared is equal to opposite squared or plus what? Adjacent square, or perhaps you can say adjacent square plus opposite square. So I'll have my 6 squared plus what there? 8 squared. X squared is equal to 6 squared is 36 plus 8 squared is 64, right? If I sum of them, I'll have that x squared is equal to 100. Square both sides, I'll have, or perhaps this is x squared. They take this square here because square root. So I'll have that x is equal to square root of 100. So x is equal to 10. X is 10, yeah? So it means that my distance here is 10. So it means that to get the question now says, look up, the question says, determine the difference between the magnitude of displacement of the body and distance by him. So I'll simply take displacement. So it means that displacement minus what the distance will give me what I want. Distance. So displacement is what the 14 minus what's my distance? 10. If I minus them, I'll have what? 10 minus 40, I'll have 4, right? 4 kilometer. So that's our option B is my answer to that question, right? All right, let's do one more example, right? Example 4 says, all right, example 4 says a train travel at 20 meter per second. So that's what velocity there. So that's V, 20 meter per second, right, undergoes a uniformly retardation of 2 meter per second squared. That's what retardation is, what negative acceleration of what 2 meter per second squared. So that it means that acceleration that is A is equal to what? Minus 2 meter per second squared. All right, undergoes a uniform retardation of 2 meter per second squared. When brakes are applied, full stop, calculate the time taken to come to rest, right? Calculate the time taken to come to rest. I'm looking for T. So time taken to come to rest, T-I-M-E, time, T. I'm looking for T. So time taken to come to rest. It means that when we said time taken to come to rest, I mean something there. I mean that time taken to come to rest. It means that the body finally came to rest. And I said that from the idea for this one, I said that whenever a body finally comes down to rest, its final velocity, that is V, is equal to 0. So V is equal to 0. That's the meaning, right? But I'm seeing velocity here. Look up in the question. I'm meaning that a train travels at 20 meter per second. Meter per second is for what? Velocity. But now I cannot clarify that this one here is for when I'm hearing that the body comes to rest. It means that its final velocity is 0. That is V is 0. So that it means that now this will no longer be V. It will be what the initial velocity, that's U. Since this one is V now, this one becomes what? U. So here becomes initial velocity. Initial velocity. That's U. That's 20 meter per second. Normally it meant to be velocity. But since the condition says that calculate the time before the body comes to rest, and I say whenever the body comes to rest, its final velocity V is 0. So since V is not 0, you cannot swap this one to what the initial velocity, because I can't have 2V in the question. One must be final, one must be initial. So I've clarified this for you. All right, the question says find the time taken to come to rest and the distance traveled from the place where the brake were applied. So I'm looking for distance there. So distance also, distance, that's D, right? D, distance D, or perhaps X in this case. Distance X in this case, because this is a question under what? Equation of uniform accelerated motion. I'm using this 4 parameter here, this 4 formula. How do I know is a question under this? Because I can't hear the word free fall. I can't hear the word for. The one we did initial, you can hear the word for freely. From here now, I can't hear anything for freely. What I'm hearing is initial velocity, final velocity, and distance. So all these things here are here. so I can check them here. So we're looking for two things there. We're looking for time and distance. So let's start with time. Let's start with getting the time. To get the time here, check. Look up. I'm given. Alright, from here, let's get time, please. Let's start with time before we get distance. For time, look up this. To get time, which formula talks about time here? Obviously, all of them. But which one is quite faster to get time? I know three things. I know my U and V and A. So it means that I know U, V, and A. I can get T. So it means that I will go from this one here. So we go from here. Recall that we said V is equal to U plus AT. What's V? 0. So 0 is equal to U. What's U there? U is 20 plus A is simply what there? Minus 2. And I have my T here. Alright. Next up, plus minus is minus. So 0 is equal to 20 minus 2T. Take minus 2t here becomes plus 2t, that becomes 2t is equals to 20. Divide by 2, divide by 2. So t is equal to 20 over 2, as in this case here. Divide here by this, I'll have that t is equal to 10 in seconds, because time to be in what seconds. Right? So I've actually gotten the time. So therefore, we have actually gotten the time. It takes the object, right? So I got the time here. Let's get the distance, right? Let's do distance. So it means that these are my option here. So I can have time 10 seconds. I'm having 10 seconds here. I should have go for this, but I'm still having what 10 seconds. So I need to confirm what this distance before I can pick any of these two, right? So distance, or perhaps yes, distance. For distance now, for my distance there, that's s. Now to get x, which one will I use from here? Of course, I can use equation 3 for my distance, right? So for equation 3, recall that we said x is equal to ut plus 1 over 2 at squared, right? Let's input value. X is unknown. What's u? U is 20 multiplied by what's time? Time is going to be 10 now. We know time, that's 10 plus 1 over 2 times what's A? Acceleration minus 2 times what's T? T is what? 10. 10 all squared, right? So 2 cancel 2 here, left with what? Minus 1. Minus 1 here. So it means that x is equals to, this is 200. 20 times 10 is 200. So plus 1 times minus 1 is what? Obviously minus 1 into what? 100 times 100 square, 10 square is 100. So it means that x is equal to 200 plus 1 minus 1 times 100 is what? Minus 100, as in this case. Plus minus is what? Is minus. So it means 200 minus 100. Hence, x is what? 100 in what? In meters. So my answer there is what? Time is 10 seconds and my distance is what? 100 in meters. So option C is my answer there. So try to solve the other questions. I'll give an assignment right now. So try to copy down the assignment and do solve them and put your answer in the comment section below. I'll try as much as possible to give you a response if you're wrong or if you're correct. Alright, if you found this class helpful, you can kindly reach out by sharing to your friend and classmates so that they can learn too. Alright, bye. See you in the next class.